Hello everyone. My name is. Well, this is not going to work. My name is Toon. I'm a product manager for Wercker. Wercker is a continuous integration and deployment platform, but also focusing on developer automation in kind of a container-centric world. And today I wanted to talk to you about CI and CD in a cloud-native world, and basically how traditional CI is kind of falling behind and what we need to change to fix that. So the first question that we need to ask ourselves is, how does this modern cloud-native world look like? How do the applications look like that we're developing today? So first, let's take a look. Let's take a small walk through history. Start in the early 2000s, where basically life arguably was pretty simple. You were deploying a single application onto a single server. Our method of deployment was FTP. Maybe you did a deployment once a week. Again, arguably life was pretty simple. Fast forward to 2010 around, and things suddenly got a lot more complex. Obviously, there were a lot more harder requirements that we needed to meet. People wanted scalability, high availability, all those things. So what we did, and what you should do when you're tackling a hard problem, is split it up into multiple components, right? So that your problems get more easy to solve. So that's what we did, both on the infrastructure side of things, with the advent of kind of Heroku and Amazon Web Services getting a lot of traction and a lot of popularity. We started deploying onto VMs. So no longer were we deploying onto servers, but we had this virtualized instance that we could deploy to. But on the software side of things, we also started splitting things up, right? So no longer did we have a single application that we were deploying, but now we have this kind of multi-tiered application structure that we want to deploy to these multiple VMs. So that also meant that our method of deployment became a lot more complex suddenly. So that meant deploying multiple applications onto multiple VMs. Don't think FTP would suffice to deploy those things. So we came up with a new school of thought, which we call DevOps. And DevOps basically allowed us to structure these things, right? It allowed us to define, all right, so how many applications do I want to deploy? How many VMs do I need? What type of VM do I need? Which application is dependent on which other application, et cetera, et cetera. And we would all define this inside scripts, right? So fast forward to the modern day. Again, applications are still becoming more complex. There's kind of a trend here. And again, we're starting to split things up into even smaller components. So no longer are we deploying onto VMs. Well, we are, but we're using containers as our method of distribution. And again, on the software side of things, we're also splitting things up into even smaller components. So where we had these kind of 3 or 4 multi-tiered web applications, consisting of 4 components rather, we now have microservices that can consist of maybe 10, 20, or maybe God knows like how many components these things will have, right? So deploying 10, 20s of components onto, you don't know how many VMs or which type of containers you're using. So what's the method of deployment here? Well, we're still figuring that out. And that's hopefully a question that will be answered by the end of the talk. So before we go further into that, I wanted to touch briefly upon containers and microservices. So containers, show of hands, who uses containers or who has heard of containers? Cool, who uses containers in production? Right. That's fine. So containers, for those of you that don't know, basically provide your applications with an isolated runtime environment to run in. And basically, I'd like to compare containers to what apt, the packet management, did to tarballs, right? So apt provided tarballs with a distribution mechanism. So this is basically what containers are doing for your applications, right? Containers are first and foremost a distribution mechanism. So the motto here is to build once and ship it everywhere, and don't worry about dependencies and stuff like that, or what version of OS you're running, etc. So with these containers, with this great technology and tool, it allows us to build microservices. So what are microservices? Basically, there's a philosophy behind this, and it says that you should write programs that do one thing, but do it very well. You should write programs that work very well together, right? And you should write programs that have an API, that could be an HTTP interface, so that they can talk to each other. Basically, this sums up the microservice philosophy. So we have containers, we have this cool tool, we have this new paradigm, microservices. Next question is, how do we run this stuff in production? I'm going to spoil the answer here, but who of you uses, or who of you has heard of schedulers, container schedulers? Also quite a lot, okay. Who of you uses schedulers in production? So, schedulers, right? This is basically the answer towards running your microservices in production. So schedulers, again, for those of you that don't know, is software that allows you to schedule, to scale up, to orchestrate the deployment of your containers across your server cluster. Across your cluster. So that, yeah, I mean, where we used to do DevOps and basically define these things inside scripts, right? Like how many VMs do I need? Which applications are dependent on each other? We still do these things with schedulers, but on a different level. So no longer are you talking in terms of VMs necessarily. You're talking on a level, okay, I want to update this new container image, and tell my scheduler to run it across the cluster. So we've basically pretty much nailed down how to run these microservices in production. But then again, the next question is, how do I get my containers there? Hopefully the answer is kind of obvious. I would say through CI and CD. So that's what we're going to talk about now, how to get our containers onto production. So the current state of CI/CD. Anno 2016 should be relatively straightforward. Your CI server picks up code changes, it executes any arbitrary amount of steps, and then produces an artifact. So let's apply this paradigm to a containerized world. And so, again, picks up the code change. That seems relatively unchanged. Your CI server should still do that. Then it should execute any amount of steps to produce an artifact. That in this case should be a container, right? This is the unit of work that we want to deploy. So what we need to ask ourselves is, okay, so how are we going to build this container? What are the steps that we need to take to actually produce an artifact that is a container? So the first answer that kind of pops to mind is Docker files, right? So this is kind of the de facto standard for building containers locally. So arguably you would say, all right, have my CI server just execute that Docker file and be done with it, and I have a container. Well, in essence, this is true. Like, this works. It does bring a set of challenges with it that we believe kind of significantly challenge how well of a container you build, how well the quality is of your container. Basically, so let's say you want to build an application and you want to add some tests to it, right? Okay, you have your testing frameworks, your test dependencies. So you basically change your Docker file to reflect these changes, to include these development dependencies and these test dependencies and testing frameworks. And then, boom, your CI server now is doing tests and still producing a container. But it's also shipping a container that includes all these test dependencies, all these frameworks that are not really necessary when you want to run this thing in production, right? I mean, this does not really adhere to the microservice philosophy that we just mentioned, right? Do one thing and do it well. No, I mean, this is a container that has testing frameworks and development dependencies. Again, you don't really need those. So how do we change that, right? Like, what is our vision of the correct way, or the worker way, if you will? Basically, the short answer to this is build your containers in two phases, right? You have your phase where you install your test dependencies, where you do all your tests. And then, even though in the second step you're going to throw away that container, you still want to run this inside the container, right? You still want to run your tests inside the container because you want to get as close to the production environment as you can get, right? Because you're working towards dev prod parity, so you want to mimic that production environment, so you can make sure that the behavior is more or less the same as in production. So, but then you're going to trash that container, the testing container, and spin up a new one, and then only install the dependencies that are needed to run this stuff in production, right? So again, build your product in two phases, a testing phase and a building phase. Seems quite straightforward, but also relatively hard to do with Docker files, right? How do you specify that you want to build two containers from the same Docker file? I don't know. So that kind of covers continuous integration. So on to continuous deployment. I mean, this diagram is pretty nice, but yeah, deployment is kind of vague and abstract here. So let's try to answer that. So continuous deployment, the current state of continuous deployment is that you would just in your deployment pipeline would kick off a script, your DevOps script, that would, Ansible or what have you, and then it would take care of deploying for you. Done, right? Again, in a containerized world, this methodology doesn't necessarily apply anymore because you're deploying containers onto a scheduler, and so that's an extra level of abstraction that you didn't have when you were deploying onto virtual machines. I mean, you're not talking to virtual machines directly anymore. You're talking to the scheduler. So the method of deployment here has changed, and the answer of how do we do this is quite similar to how you should fix your build pipeline, and that is split it up into 2 phases. Done. So the first phase is to push to a registry, where you just take your artifact that your build pipeline created, and take that artifact and push it into Docker Hub or any other registry. And then as a second step, just notify your scheduler and tell them like, okay, hey, I have this new container image, and I want you to take care of it and deploy it onto production. But as you can see, neither of those really significantly describe a deployment, right? I mean, the first one is pushing to a registry, whereas if you think about deployment, it means taking your app, putting it onto a server, and then actually executing it and making sure it runs on your servers. But pushing to a registry, that's like uploading a file, right? It's not really deployment. It's file uploading. And then the second step is notifying your scheduler. It's also not really deployment, right? I mean, it basically says like, it's an API call. It's like, well, here's a new container image. Take care of it. It's not really deployment either. And this is kind of true for building like a build pipeline, right? I mean, building is not really sufficient anymore when talking about complex applications because you want to split up your build pipeline into multiple phases. And this is kind of what we've been seeing as a trend at Wercker. Oh, so this is a nice image of building and deploying. We'll just stick over that. So yeah, so build and deploys are insufficient is what we're seeing. So build is basically test your stuff, then run any arbitrary amount of scripts. Like, I don't know, probably some of you have, in your CI setup, have used like inline scripts that are unique to your CI setup. Basically, you define somewhere in the UI or whatever. So these scripts are not version controlled, but they allow you to execute some behavior, yes. But they're not version controlled, and that means if you introduce a change, how do you know if that's a breaking change? How do you roll back? Also, if you hire a new employee, it's like, oh, look at our CI setup, and here are all these scripts that are defined in this UI. And like, there's no real overview of what this stuff actually does, right? So yeah, so any arbitrary amount of scripts, and then the actual build process of producing an artifact that can be run in production. So deploy, it's the same story, right? It's actually pushing something to a registry, then doing some other things that are arbitrary to your setup, and then notifying a scheduler. And this is what I think, or what we think rather, needs to change when talking about CI and CD in a containerized world. We need to move away from build and deploy. I think we need to stop shoehorning builds and deploy, our workflows rather, the developer workflows, and stop shoehorning them into builds and deploys. We no longer, applications have become too complex for the verbs build and deploy to be sufficient. And this is something that we've been working on for the last couple of months. It's something that we've called workflows. But first, some use cases. So where this could be interesting, right? So the first use case is, okay, you want to build your base image, right? So you have, let's say you're building an application, it's containerized. So a useful thing to do is build a base image that contains all your developer or dependencies that it relies on, that are necessary for them to run in production. And then based on that base image, you want to create 2 more images, one that is ready for development, so you want to use that image on your local host for development, and another image based on that base image that is used for it to run in production, or any arbitrary amount of steps, any other images that you might want to produce, maybe one for staging, for QA, whatever environment you can think of, right? But they all build upon that base image. The second one is interesting. That was a user that I talked to, and he basically wanted to deploy his applications to staging. So that's one pipeline. But then another pipeline, he wanted to kind of ping that staging server, and it's like, okay, after 10 minutes, is everything working? You would do like an API call or whatever. If that API call returned, okay, everything's fine. And after 10 minutes, you wanted to, okay, it's fine, let's deploy to production. I don't know, that seems like an interesting use case to you. The third one is pretty interesting, I think, and one of the most interesting ones. So you're building these distributed applications, right? So these distributed applications consist of multiple microservices. So what that means is if you push a change to one of these microservices, that means any number of other microservices will have to be tested again in order to see if anything breaks, right? So you want to run integration tests cross application. No longer do we have a single code base. We could have multiple code bases that are all dependent on each other. So again, how does this fit into a traditional build pipeline, right? It doesn't anymore, because you're not building a single application anymore. You're building things that consist out of multiple things, so you need workflows that facilitate that. The fourth one, create multiple images for one Git source. So consider the use case where you do have like one code base that maybe consists of your front end and your API, for example. So you would want to run two pipelines or two workflows based on that one Git push that you did, right? So one would be building your front end, and the other one would be building your API or your back end or whatever code you have in that code base. So based on these 4 use cases, we came up with a list of key properties. So quickly going over them. The first one, you should be able to create as many workflows as you want, right? Again, so in order to facilitate and not shoehorn into build and deploy, you should be able to create any workflow that you want. Build prod, or build staging, build QA, not just build. Workflows should be chainable. This is interesting. So, I mean, your build base image should be able to trigger build dev, and your build dev should be able to trigger deploy dev or push dev. Kind of in the spirit of your build pipelines should trigger a deploy pipeline, right, in the old world. The third one is workflows should be able to build on each other's artifacts. So what that means, every pipeline produces an artifact. What if I want to take that artifact and then build upon it in my next pipeline? Right? So I produce a container, I take that container onto my next pipeline, and I want to keep on doing stuff with it. Number 4, workflows should be able to run in parallel. Also important. So again, the use case where you would run two workflows simultaneously based on one Git commit, right? So you want to run those two in parallel. Number 5, workflows should be version controlled. So we briefly touched upon this, but you no longer want to do these inline scripts that are not easily found in your CI UI or whatever. No, you want to see where a breaking change was introduced. You want to see how your workflow, what your workflow is doing exactly. So you want it to be version controlled. And last of all, and again, something that we touched upon in the use case, is that it should be able to work cross-application. Again, your applications or your projects consist of multiple applications. You want to be able to trigger pipelines cross-application. Right? So basically summing up, with Wercker, we're trying to take automation to the next level. And we're trying to kind of become, this is a kind of interesting comparison, but we're trying to become the if this then that for development workflows, right? We want to provide you with as much automation and as high abstraction as possible, so you can create whichever workflow works for you in this kind of cloud native containerized world. And that pretty much sums it up. So thank you. And questions? Yes.
Manual quality assurance, where that takes place and how, because it's sort of tricky for some people coming from big enterprise world
Sure.
to get stuff out directly to production.
Mm-hmm.
So when and how to efficiently involve manual verification?
Yeah, I mean, in the future, so again, right now we have pipelines that get triggered automatically, right? But I can imagine, like in the future, you could definitely have a workflow whereby, this is a workflow of type, like manual, right? Right now we have a workflow that is of type Git, so you listen for Git changes, and we have a workflow that listens on other workflows, right? So in the future, I can imagine a situation whereby I would say, okay, this workflow needs to listen for manual input, right? I mean, this is, because we're setting up to be as generic as possible, right? So implementing a newer version of a workflow is not something that is far away, right? I mean, it's not in there right now, but it's something that is on radar, right?
Okay.
Other questions?
Security?
I think we'll hear all about that in the next talk.
Okay.
I'm just kidding. I don't know why you want to know, but
It's just security when it comes to the actual deployment to production world. And like, what verifies that's actually good piece of code goes to production, except the automation test. What if the automation tests were not covering enough all the critical paths and so on?
I feel like that's, I don't know, that's not
Stupid
really.
question.
Well, it's not obviously it's not a stupid question, but I don't know if that's necessarily the responsibility of the CI server to make sure that you've written the right tests, right? I mean, there's always going to be human error involved in this. Like that's always the weakest link in any automation or workflow, right? It's human error. So don't know if we can do too much about that, unless someone knows. I'd be happy to listen.
Well, it should be part of the development cycle. I mean,
Sure.
creating tests is part of development. And you are not deploying anything until after development has been finished. So that should be sufficient enough for the quality of the tests.
The other funny part about this deployment workflows, so basically we're thinking about having a workflows for a data-driven application. So it's fine if application has 2 or 3 microservices that are Spring Boot applications or whatever, that is sort of a single web server having a single database. So let's say we have 2 or 3, one database node, one application server node type of applications, and no databases talk to each other, they are isolated. But what if some of the applications have Elasticsearch or Hadoop under them? What is the general difficulty? We are facing difficulties with having the workflows for data-driven applications that have Elasticsearch in, or Hadoop in, or Spark in. And do you have any solutions for that to solve the problem of data-driven? Yes.
It's an interesting question. Don't think I have a solution necessarily. Not really in the business of data-driven applications. So, yeah, I don't really know, unless someone else can.
It depends on what you need, right?
Yeah.
I mean, there's definitely, you can use containers with Elasticsearch installed in your integration tests. And then you obviously can fill these containers with your data sets or a subset of that, and then write integration tests or other unit tests around that to make it work. I don't know if that's what you're referring to. Do you need like specific data triggers in that?
It's more like Elasticsearch is easy because setting up a cluster of Elasticsearch is simple by unicast, but when it comes to Hadoop, here comes the tricky part of making sure that that monster works and reproducible as the microinfrastructure for a commit.
Yeah, Hadoop is a hard thing. And you could obviously set up a cluster that runs the workflows against the cluster. If you have a very intricate setup, could be worthwhile in doing that. Otherwise, I'm not super excited about running Hadoop in a containerized way and sort of spinning up different containers with Hadoop and getting your data sets in there and making sure everything works. So yeah, maybe set up a separate cluster for that. But Elasticsearch is definitely something that could work.
Yeah, Elasticsearch is easy.
Don't use Hadoop.
Wouldn't that be part of the scheduler?
Yeah, but again, so that assumes that's running, right? So it's not part of your sort of CI/CD workflow per se in terms of it being containerized or not. It would, be a separate cluster running on top of the scheduler that you would run your tests against. that would be the, I think, best solution.
And don't run Hadoop.
Cool. So yeah, I guess that's it for me. On to the next one, I'd say.